In here, we are expressing each number as a product of its prime factors. It is always great to know the divisibility rules. Our next question is 156. We are doing the same steps again. Knowing the divisibility rules help us to proceed very faster. To get the LCM and HCF of the following, we first express them as a product of primes. Highest common factor or HCF is the product of every common prime present in the two numbers. So we will look for the numbers common between them and we have to multiply the commons to receive the HCF. LCM is a product of highest power of every prime present in the number. So we will take the highest power of every prime number present in the prime factorization of both the numbers and multiply them to get the LCM. As we are taking the highest power, we took 2 raised to 4 instead of 2 from 50. So our HCF is 6 and LCM is 3024. Second part of our question is verification. We put our above founded values in there and our numbers 336 and 54 as A and B. But we won't be equating the numbers. We have to find the values and if they are equal then we can prove that. And when the both the sides are equal we have proved that the LCM and the HCF rounded by us are correct. As in here both the sides are equal, LHS is equal to RHS.
will never have a 5-minute prime factorization and continue to have 2 and 3 for whichever value n takes. We are just proving this in here.
For the answer to be composite, we have to show a product of more than two factors. It is given that there is a circular path and Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. We have to find that after how much time they are meeting at the starting point. For it, we need to find the LCM of 12 and 18. 18 when expressed in terms of its prime, 18 is equal to 3 into 3 into 2 and 12 is equal to 2 into 2 into 3. LCM will be 3 square and 2 square, which is the highest power of the every prime present in the number. That is, LCM is 36. Now we are just concluding. A number can be set terminating decimal when its q is in the form of 2n into 5n. In here, q is in the form of 5 raised to 5, which means that 5 raised to 5 into 2 raised to 0. It is in our required form. Even though we are only looking at the denominator, it is great to write the numerator also in its prime factors form. Writing the numerator in the form of primes is good because we could sometimes cut from the denominator and numerator. In here also it is of the form 2 raised to 3 into 5 raised to 0. I am adding 5 raised to 0 because it just means 1. And you can simply say that it is of the form 2 raised to n into 5 raised to n. In conclusion, 17 by 8 is terminating decimal. In here, we will be only looking forward to the questions which have been done from question 1, which is question 1 and question 2. As we have found that the first question is terminating, so we have to find its decimal expansion. So in here, the denominator is 5 raised to 5. What we are doing in here is we are multiplying it with 2 raised to 5. That is, the denominator becomes 1 and 5 zeros. We also know that we have to divide both the numerator and denominator with the same number if we are multiplying any one side. From my calculations, you would see that we are doing the multiplication. 2 raised to 5 is 32, and this 32 is for the numerator. As we can simply say that the denominator is 1 0 0 0 0 0, 1 and 5 zeros. So 13 into 32 is 460. Which is now divided by 1 lakh. It is 0.00416. We had already seen that this number is terminated. As said before, 1 into 17. So we can cut from the denominator. We have to multiply the numerator and denominator with 5 raised to 3. This number is rational because it is a terminating decimal. This is an irrational number as the decimal is non-repeating and non-terminating. This is a rational number because it is non-terminating repeating decimal.